the stream. Now we are live on YouTube. So I'm just starting the live stream. Okay. So we will be starting the quiz now. Very small quiz, just a few questions. So first thing everyone to kindly please join this name 17748. Everyone, kindly please join this class. Someone still trying to join. First question on your screens, PCB surface. Yeah, first question on your screens. Which type of gold fingers has gaps in the plating? We discussed about which is also called as intermediate. people answered uneven. No, not uneven. And few answered. No one has chosen correct answer. That's really weird. Segmented. Segmented means having gaps, right? Please go back and listen to the previous session. No one answered correct. Segmented or intermittent gold fingers. Both are same, which will have gaps. Next question on your screens. What does ENIG stand for? PCB finish. What does ENIG stand for? See, again few people answered incorrectly. Electroless nickel immersion gold. We discussed about it. Not electronic. Electroless. Okay, not industrial. Immersion gold. Let me see. Nihal answered fastest and correct. Then Sri Krishna and then Inamal. Which standard specifies requirements for ENIG plating? We discussed about the standards. There is something called IPC standard which specifies about the ENIG plating. What are the requirements? We discussed many things. See on options carefully. Many people answered IPC A600. No, that's not. IPC A600 is different. Okay, and IPC 4552 is the correct answer, and IPC TM650 also we discussed. IPC TM650, in IPC TM650 it describes about quality control tests like ROS test. Okay, ROS test is described. ROS test and tape test, these are described in IPC TM650. And ENIG plating, electroless nickel immersion gold plating, is described in IPC 4552. Sri Krishna on the top and then Nihal. Okay. Next question on your screen's computer. What is the primary purpose of tape test? What is the primary purpose of tape test? Option A, verify gold fingers. B, check plating addition. C, test for ionic contamination. D, measure electrical resistance. What is the primary purpose of tape test? And your time is out. Many people answered option 4. Measure electrical. Okay. Many people answered option 2. Check plating addition. Okay, perfect. And one has chosen test for ionic contamination. Test for ionic contamination is actually ROS test. Okay, resistivity of solution extraction. That is, test for ionic contamination is ROS test. Tape test is to check the plating addition. Okay, not contamination. For clean, see, ROS test is also called as cleanliness test. Okay, what you answered is this is the cleanliness test. We need to check the ionic contamination. We need to perform cleanliness test, which is nothing but ROS test. Tape test purpose is to, the main objective of the tape test is to check the plating addition. Yeah, Nihal on the top. Let's see. Next question on your computer, please. What does the ROS test measure? Even after discussing, again incorrect answers. How? And one answered copper layer purity, not copper layer purity. Okay, it is not to ROS test is not there to check the purity of the copper layer. It is there to check the overall cleanliness, ionic cleanliness. Okay, ionic contaminants. So we discussed examples also. So how, I just don't know whether you remember them or not. We discussed the adipic acid. Adipic acid is used as an activator for soldering. Okay, which is considered as an ionic contaminant. There are many ionic contaminants, like different ions are there. So in ROS test, the entire ionic contamination is expressed in terms of NaCl equivalence. So it is the overall ionic cleanliness. Okay, how many? See, we discussed the main chemical used in the ROS test is isopropyl alcohol, 75% isopropyl alcohol and 25% distilled water. Okay, and PCB is when placed in isopropyl alcohol, so it is like a physical dissolution process, not completely chemical reactions. It is a physical dissolution process in which the ionic contaminants are first dissolved in the isopropyl alcohol. So once they are dissolved in the isopropyl alcohol, the resistance is changes. The resistance changes. Okay. So whenever we add any impurity to any kind of solution, the resistance varies. Based on how this resistance is varying, depending on that, the cleanliness can be determined. That's why it is called as resistivity of solvent solution extraction. Okay. So resistivity, first we will be determining the resistivity or else resistance. So based on that, how pure the board is, how much ionic contaminants it is having, that we can be determined. Okay, it is about completely ionic contaminants, not copper layer purity. For examining the copper layer purity, there are different other methods, metallurgical, other methods in which we can estimate the purity of the metal. So rose test, the main aim of the rose test is to measure the overall ionic cleanliness, not the copper layer purity. Okay. So those who missed these kind of questions like rose test and tape test, kindly please go back and watch those sessions where we discussed very clearly about rose test and tape test. And scoreboard, same Nihal on the top and then followed by Sri Krishna, Inamal, Charan and Anirudh. Guys, come on. Next questions on your screen. Complete the sentence. Uneven gold fingers are also common. Uneven gold fingers are also common. Option A, segmented. B, non-standard. C, standard. D, intermediate. Two people answered segmented. See, if you answered segmented, actually segmented fingers and intermittent fingers both are same. So it's like another name. Segmented or intermittent, both are same. Okay. And fortunately many people answered correctly, long short fingers. Uneven fingers are also called as long short fingers, not segmented. If see those who answered segmented, then why don't you answer intermittent? Both are same options. It is for segmented, another name is intermittent. Okay. And those fortunately no one answered standard finger. Okay. So actually we should call it as regular or standard, or there is one more name also. So those who know about the another name for regular fingers, post a message in the chat box. I'll check. Okay. Yeah. Next question on your screen. First, before that, scoreboards on your screen. Yeah. So Charan now is in third position. Sri Krishna in second, and Nihal is in first position. So Nihal has a total answered 5 correct answers in a row. Great. Next question. Which document provide test methods for printed boards? IPC TM650, ROHS directives, ISO 9001, IPC 455. IPC TM650. Yes. So 4 people answered correctly. IPC TM650, which describes about methods, test methods for printed circuit boards like rose test and tape test. There is one more test called as chromatography, ion chromatography test, which we haven't yet discussed. So ion chromatography test, rose test and tape test, all these are described in IPCTM 650. So these tests are mandatory. So it's like a standard. Before this specification came into picture, every manufacturer used it to perform their own tests to assess the quality. But once this IPCTM 650 came, now all the industry, like all the manufacturers, the uh, quality assessment tests become standard. Okay. So this is the main reason for standardization of the tests to be performed, test methods to be performed for PCBs. And ROHS direct use, you know about ROHS, we discussed very deeply about ROHS in consumer safety as well as environmental safety. So ROHS means restriction of hazardous substances. So where we discussed about 10 banned substances starting from lead. Okay. And IPC 4552, you know very well about it, IPC 4552, right? We discussed about IPC 4552 as well. So ISO, you know about ISO? So ISO is like a it's like a standard organization. Okay. So completely it is not related with our particular thing about what we are discussing, the current context. It doesn't even belong to our context. So I just don't know why. Yeah. Okay. Fortunately, at least one choose an IPC 4552 because you are able to identify that answer should be at least between among between these two. Uh, Fortunately, that's good. Yeah. See, this ISO 9001 is like it's like uh, ISO means International Standard Organization, which is ISO 9001 also specifies about some system, okay, quality management system. So if you are having ISO 9001, if your company is ISO 9001 certified, then it is like having some authenticity, or else it's like a trusted, okay, so authentic, so that you are following all the quality standards. But these quality standards are not actually the test methods, okay. These test methods like a rose test or a tape test or ion chromatography test, these tests are not described this ISO 9001 is like a generalized one, okay, about quality management uh, of your company, but it is not specific for PCB. Only these three things are specific for PCB, and even ROHS is not very specific to PCB only. So it is like a general restriction of the hazardous substances, not only in PCB, could be in other different applications as well. But whereas IPCTM 650 and IPC 4552 are completely related to about our PCB related thing. So I'm just going to the scoreboard and coming to this IPC 4552. You know about it, right? So IPC 4552, it is like a specification for electroless nickel or immersion gold, where we discussed about the thickness of the nickel and and the thickness of the gold 0.05 to 0.15 micrometer. We have also converted these micrometers into micro inches, and also for IPC 4552 also talks about not only actually thicknesses about these nickel, gold and copper, it also talks about shoulderability, okay, shoulderability, so all these kinds of things. So leaderboard, again Nihal on the top position, rest all same. Next question, what is the nickel layer, why is nickel layer important? So those who answered it improves conductivity, that's actually wrong. It does not improve conductivity, and it provides the color, not for coloring purpose. Already copper itself is a good conductor, okay. So it is cheapest layer. No, it is not. See, first one is I already told you. Even we also add, sometimes we also add cobalt. I told you in making of a gold fingers, we also add a few percentage of cobalt as well, because cobalt increases rigidity. Okay, it acts as a barrier and it increases the rigidity. Next question on your screen. What is a potential issue? Those who know the primary objective of air test can easily answer. Option A, high resistance, shoulder mass discoloration. Option C, poor plating adhesion. Option D, incorrect board dimension. So many people answered poor plating adhesion, and one answered incorrect board dimension. No. With a tape test means it's not like a measurement tape, okay? So we discussed about something called 3M company. We discussed in very detail about the complete analysis of 3M company, when it when the first sale happened, and what are their products, so what kind of chemicals they have been manufacturing, its turnover, its ranking. I think it's 102 or 120. I don't remember. In the rankings, it got maybe in 20, somewhere in some year it got a 102 or 120 rank. I think so. So we discussed very in detail about it. So because of its high revenue, high sales, so it got it was selected under top 500 companies which produced these 3M tapes, and those 3M tapes are used commonly used for tape test. And the main objective of the tape test is to check the plating adhesion. Okay, so see, we are in ENIG process, we are having three layers, right? So sandwich of three layers. So what are those three? First, at the bottom we are having copper layer. Above copper we are having nickel layer, and above nickel we are having gold. Okay, total three layers: copper, nickel, and gold. So these three layers, like when we apply the tape and we just try to drag it, so if the gold uh, is uh, coming with the tape, that means it is a clear indication that there is poor plating adhesion. Okay, it is used to test the adhesion, how adhesive forces are there among these three layers. So ideally the gold should not come, it should very firmly stick, it should very firmly attach it to the nickel layer, and consequentially, so nickel layer should also be very strongly attached with the copper layer. So these three layers should be in good adhesion. Okay, so that is the main objective of the tape test. So again, not incorrect board dimension. So for board dimension, we can measure it with normal measuring tape. Here I didn't, so that's why those who didn't attended the previous session, so this would be different. So still there might be few people who are thinking rose means rose flower, isn't it? Those who not attended the session where we discussed about rose test and tape test, still they are thinking it's a rose flower. I know about it. Okay. Yeah. So I'm going to leaderboard. See, actually, this shoulder mask for shoulder mask discoloration also there is one test. Okay, so last time we got one option, right? Maybe in the previous question, IPCA 600. See, actually we discussed about IPCTM 650. In IPCTM 650, it is it is like a specification for different kinds of testing methods for PCB, for quality control assessment. So like rose test, tape test, and ion chromatography test. So this IPCA 600, it is not 650, it is 600. IPCA 600. So this is also called as visual inspection test. IPCA 600 is also called as visual inspection test. In this visual inspection test, we will be checking uh, about this shoulder mask discoloration. This comes under visual inspection test, which is prescribed in IPCA 600. Okay, whereas this tape test is prescribed about these methods for for PCB methods, like testing methods. These are prescribed in IPCTM 650, not 600. In 600, 600 is also called as IPCA 600 is also called as visual inspection test, where we will be performing some visual tests. So these tests can be done manually, but mostly we will be using machinery, where there would be a high AI cameras that would be having high quality, high megapixel, and the PCB will be seen in monitors at higher magnification, and they will be checking many things. Usually, sometimes like mostly they will be using the magnification of around 4x to 10x. Okay, that means they will be magnifying the PCB starting from 4x times to 10x times. So it depends upon different companies. Some companies use 5x times as a standard practice. So like that, usually from 4x to 10x times they magnify the PCB, and under proper lighting. Okay, lighting, they will be also having some lighting setup, uh, good lighting setup. and they will use some powerful lenses, not ordinary lenses. They will be having very expensive powerful lenses, under which these PCBs can be magnified from 4x times to 10x times, and these there will be a monitor through which they will be assessing if there's a uniform color or not. Okay, under visual inspection there are multiple things that they will be assessing. They will be having a sheet with them. They need to tick each and everything whatever they verified during the quality control. They need to tick for each and everything. So they usually test for something like a uniform color, and cracks if there are any cracks, and minor color variation. Sometimes, see, we are printing silk screens, right? So usually whatever the image that you are trying to print may be of sometimes, but due to their machinery, due to lack of accuracy, or maybe some technical issues or technical glitches, so there might be the coloring variations. Now see, let's say here we are having some tree image, so it should be uniformly of same color. Sometimes there would be a gradients. At one area it would be having much thicker, and another area it would be lighter. So these kind of coloring variations, whether if it is everything uniformly spreaded or not, all these things are verified. And shoulder mask discoloration, this is also verified during visual inspection. Visual inspection, which is described in IPCA 600. Okay, so this IPC TM 650. Uh, Also, there is one more thing called thermal stress test. Okay, we will discuss about these things in actually higher courses. So here we gave only the introduction to tape test and rose test. IPC TM 650 and IPC A 600 and IPC 4552. Yeah. So Nihal on the top position. Anirudh has the highest answer streak of 3. Good. So the IPC 4552 standard primarily focuses on which finish? Very, very simple question. Our previous session is completely on IPC 4552. The IPC 4552 standard primarily focuses on which surface finish. Yeah, everyone answered correctly except one. One answered C. Organic shoulderability preservative. No, no, no. Not at all. Yeah, we have podium. Let's see. The third position, Inamal. Congratulations. Let me do sound effect. Because these tests are considered by terminology IPC 4552, TM 600, IPC 600A, smaller techniques, those tests, rate. Go back and watch those sessions. Yeah. See, this is one test. This is one specification. IPCA 600. IPCA 600 is also called. This specification is also called as acceptability of printed boards, because every PCB first it needs to be acceptable, right? So this is also called as acceptability of PCBs. So what kind of PCBs are acceptable? That is prescribed or documented properly in IPCA 600. Okay, it is also, it is the globally recognized standard. So all the manufacturing companies follow some specifications, okay, some global standards like IPC 600. So there is one more thing, IPC 6012. I will show you. See, these are like global standards. See, usually you don't find about these standards in normal courses. So as we are giving you the opportunity, it's best for you to learn about it. See, these are different kinds of standards. See, all these are different standards. IPC 2581, IPC 2610, IPC 2221, 42s, 2223, 2226. So I just don't know whether you remember or not. We also learned about IPC 2221. So if you do not have idea about it, go back and just watch them. So among these also we learned a few IPCs. Okay. Yeah. So this is IPCA 600, acceptability of printed boards. After, see, acceptability of PCBs is very essential. So here it is given about a few IPCs. Okay. So basically IPC means Institute for Printed Circuits. So this is one kind of organization, so which usually publishes globally accepted standards for PCB design. So this specific thing is for primarily for PCB only. Okay, as the name itself suggests, Institute for Printed Circuits. So it publishes globally accepted standards for PCB design, fabrication, and assembly. These standards serve as a common language between designers, manufacturers, and testers, ensuring consistency, quality, and reliability in the electronics industry. So IPC 2221 General Design Standard for PCBs, IPC 42s Sectional Design Standard for rigid PCBs, IPC 6012 Qualification and Performance Specification, and IPC A600 Acceptability of PCBs, IPC A610 Acceptability of Electronic Assemblies. So IPC currently has more than 300 active standards and more than 1000 standards in its resource library. So around total 1000 standards are there in resource library. Out of these 1000, so more than 300 standards are actually incorporated by all the manufacturers. Okay, in their professional manufacturing procedure, starting from JLC, PCB, all the companies, all famous manufacturers follow this Institute for Printed Circuits. Whatever the documentations which are published by IPC, they are considered as global standards because they ensure that much of professionalism and standards. That's why these are being accepted by many organizations. So in this specification, completely very detailedly explained all kinds of things. So around out of 1000 standard resources, around 300 active uh, 300 active standards are being used. Okay, committees of volunteers from across the electronic industry draft, edit, and vote on IPC standards. So it's not just, it's like a huge community, not just one or two people cannot do this kind of a huge specification. So many hundreds and thousands and millions of people across the globe, not just from one or two nations, across the globe, there are so many committees, so many communities, and different volunteers, all from across the globe. Many highly experienced experts in the field of electronics. So they draft, they edit, and vote on the IPC standard. So if one standard is considered, acclaimed as a global standard, so before, behind that there are so many things went on. Starting from drafting, there will be a drafting committee, there will be an editing committee, and there would be a voting panel. So everyone needs to poll their votes, and they need to share their suggestions and everything. So many researchers, and everyone publishes so many things, could be like graphical analysis, so many analysis are there. So after all these scientific analysis, so they will be publishing these standards. Okay, so committees can include people from around the world, as member can participate via in-person meeting, teleconference, and email. The association provides validation service programs, including a standards gap analysis that help organizations address manufacturing issues and determine what they need to do to reach compliance with the standard. See, this organization is not only IPC is not only just uh, publishing these global standards, but they are also helping the organizations, uh, uh, companies, how can they manufacture the PCBs which are compliant with the global standard. So they are giving trainings, R&D, research and development, and outreach activities are they are performing outreach activities, not only just publishing the documentation, but they are also training the companies how to maintain how their PCBs should be compliant with the global standard and should reach the manufacturability. Okay. Yeah. And IPC, what is IPC PCB? Since IPC creates standards for the electrical and electronics industry, it also plays a crucial role in producing standards for PCBs. Okay, so they are doing so many kinds of standards for electrical and electronics. So at every stage of production, see, already we learnt about manufacturing of PCB. There are different steps, isn't it? So how many of you gone through our previous session where we discussed about itching of a PCB, chemistry behind itching of PCB. See, we discussed many things, right? See, for every stage of PCB, there are so many intermediary stages. At every stage, this IPC is having their own standard that needs to be followed. So from this you can understand PCB making is not just only about drawing the schematic and doing routing, exporting into Gerber and placing the order. It's not only that. You need to follow the standards. Okay. At every stage of the PCB production process, including design and manufacturing. So IPC is an association that was founded as a collaboration of 6 printed circuit board manufacturers in 1957. This association was formed to set the standards for PCB designing and manufacturing. So it was started, all the things IPC was started in 1957, where 6 manufacturing companies, PCB manufacturing companies, collaborated with each other and unanimously everyone formed an association, IPC, in 1957, Institute for Printed Circuits. And this association, from since 1957, it was playing a leading role. So in this association was formed to set the standards for PCB designing, okay, and manufacturing. Later in 1977, the name was changed to interconnecting and packaging electronic circuits. Okay, so actual name is IPC. Actual IPC refers to Institute for Printed Circuits. So in 1977, the name was changed to Interconnecting and Packaging Electronic Circuits. So this resulted in the association of more electronic companies with the IPC association. So by 1998, after the name has been changed, many other companies also joined the IPC association. By 1998, the name was changed as most of the people disagreed with the name, and the official name adopted was IPC, along with the tagline Association IPC, along with the tagline Association Connecting Electronics Industries. They adopted the official tagline Association Connecting Electronics Industry. So that is their tagline. So IPC is an association for connecting electronics industry. So now all industries started coming forward and merging with, associating with IPC. So different classes, okay, there are so many classes, different classes of IPC in electronics manufacturing. So there are class 1, class 2, class 3. Okay, class 1 deals about general electronics, very general electronics. And then class 2 deals with dedicated service electronics. And class 3, it talks about high performance or environmental electronics. Okay, environmental. So not only just making a PCB, it should be RoHS compliant, all these things. So environmental safety is also considered in class 3. Okay. See, these class 1 principles are used for consumer devices that we use in day-to-day life, basic industrial control. And class 2, they are used in communications, infrastructure and medical instruments, which, see, for class 2, there should be uh, failure is not the correct thing, right? For medical instrumentation, so failure is not acceptable. Let's say you're working on some automated heart surgery machine. So if you think, if there's a medical, so if there's any failure inside, electronic failure, so is it acceptable? No, right? So in medical related instrumentation, uh, failure is not at all the option. So that's why for that separate kind of under separate category specifications are provided. For different categories different specifications are provided. And in class 3 avionics and space electronics, whatever the satellites that are being manufactured by ISRO or NASA or at Suchna, like CubeSats, so we follow class 3 specification. We strictly abide by them. So there is no chance for violation of class 3 principles at Suchna. So avionics and for space electronics, like military standard application. Okay, for military grade, these are the household grade or consumer grade. Okay, general consumer grade. So these are military grade, advanced avionics and space electronics. So there are so many advantages of following IPC standards, like improved reliability, better manufacturability, regulatory compliances, enhanced communication. See, we discussed about impedance formula. So who told about those impedance formula? See, that's not only just what I told. It was prescribed. It was clearly about that characteristic impedance formula was clearly documented in IPC sections, IPC classes, isn't it? So that means they did so many experimentations and then they came to those conclusions. Okay. So by following the characteristic impedance, what is the advantage? Characteristic impedance formula plays an important role in high speed communication buses. There is something I told that uh, currently industry follow 50 ohm standard, 50 ohm and few 100 ohm standard. So usually 50 ohm is chosen as the standard impedance for high speed data communications. Okay, every component, see, every component will have three properties, RLC parameters. So every component will have some resistance in it, some inductance in it and capacitance in it, RLC. Okay, so these RLC can cause us impedance. So resistive impedance, like we call it as resistive impedance, or else resistive, or else normal simple resistance caused by the resistive element. And then coming to the inductance, we call it as the reactive impedance, isn't it? Reactive impedance. Yeah, capacitive impedance and reactive impedance. All these three parameters, see, even the inductors, for inductors, L in RLC parameter, L is dominating, inductance is dominating, but still it is having L and C inside internally. Okay, so even a coil, for coil we usually use inductor symbol, coil symbol, right? When placing in schematics for any coil, we use inductor symbol. But not only inductor, that it doesn't necessarily mean that it is not having resistance and capacitance. So capacitance, RLC parameters are present, okay, always present. But what is the leading one? Okay, whatever is dominating, that specific symbol we usually use. If a resistive element is dominating, we use resistor symbol. Okay, if inductance is dominating among these RLC parameters, then we use inductor or coil symbol, inductor symbol for coils. Okay, but all these three parameters cause impedance. Okay, we need to discuss about the characteristic impedance. We already discussed what is characteristic impedance. So if you forgotten about the characteristic impedance, go back to that session and just check out what is the characteristic impedance. Z naught is equal to, we discussed the formula as well. Yeah, so like this, everything is prescribed in different standards. These are all standards for making a PCB. Okay, see, all these are different standards. So many standards are there. So if we keep on discussing about standards, it will take entire year. Okay, not just 1 or 2 days. It will take entire year to to completely discuss about all the standards. So those are very huge documents. So what we are giving you is the overall essence. Okay, overall essence. Whatever that is needed for you right now, we are giving those uh, essence. So they are like a vast ocean. Whatever giving is like fruit of it, out of it. So kindly please go through the previous sessions and yeah, someone posted flush. Yeah, perfect. So regular one, regular uh, gold fingers are also called as flush type. Okay, so there actually it is a regular one, but there in the quiz it is mentioned as standard. It is also acceptable word, standard or regular or flush. Okay, and then coming to the next one, segmented or intermittent, and then another one is uneven or long shot, uneven or long shot. Yeah, see, I just don't know why you missed that question. uh, which kind of gold fingers have gaps? That is very simple, right? I will show you the image. Those who answered incorrectly, see, we are having gaps right over here. So this is called as segmented or intermittent gold finger. Okay, segmented or intermittent. So uneven means one is it is also called as long shot. Long shot gold fingers. See, one is long and one is short. One is long short short, long short short, long short short, like that. So and there is one more thing that we need to discuss. So if you are using gold fingers, so if you just check out this PCB, so I just want to invite your observation. I request you to observe this particular image. So what have you observed in the borders? Okay, can someone just, what do you think, what's your observation in borders? Any idea? What do you observe?
They don't have sharp edges.
Yeah, repeat.
They don't have sharp edges.
Yeah, they do not have sharp edges. So when you are using gold fingers, sharp edges are not allowed. Okay, that is the specification. Okay, it's a kind of one industry standard. So if you are using, it doesn't matter whether you are using intermittent or segmented or whatever, maybe long shot, uneven, or it could be uh, standard or flux, whatever you take. Okay, even whatever one, non-even or even, whatever maybe. So what kind of, no matter if you are using gold fingers, you are not supposed to put a direct sharp edges. So you need to use see, if you just measure the angle over here, so what do you think the angle could be? So it should be 45 degrees. Okay, angle should be 45 degrees. So the edges should be not sharp edges. So we need to put 45 degrees angle. Are you there? I think you left the session. Okay, fine. So you need to put around 45 degrees angle. And not only 45 degrees, you might ask me a question. I put 30 degree. You can also put 30 degrees. Okay. So usually 45 degrees is the standard, and occasionally due to, maybe due to in certain, under certain circumstances and scenarios, uh, very rarely we will be going it with 30 degrees. But 20 degrees, don't go to 20 degrees. Use either 45 degrees is the best thing. Okay, 45 degrees. So go with 45 degrees. So if you measure the angle, if you just take an imaginary, if you just draw an imaginary line over here and you measure the angle in the anti-clockwise direction, the angle should be 45 degrees. So angle is taken, inclination is taken in the anti-clockwise direction. It is measured in the anti-clockwise direction, and it should be 45 degrees. So never put sharp edges. Let's check one more image, because there are few people who don't know about this particular rule. They directly put sharp edges, which is not at all acceptable. See, let's check this image if they are using 45 degrees turn, or see, actually it is not clearly visible in the image, but I can see it is not having sharp edges. Okay, see, those who don't know about gold fingers, they think this is the gold finger, isn't it? Gold finger. That is not the gold finger. In PCB, that is not the gold finger. I think I need to specify in PCB, or else I'll get different things. Gold fingers in PCB. See, and also people will also add something like this. Okay, just remember. Usually they keep some empty space, at least for the card insertion. Okay, like inserting, mounting, like. So let's check some other image if they are using the sharp edges or. And also one more thing. So if you are using something like gold finger, in that particular region there should be no silk screen. Okay, if you are using gold finger at that specific region, silk screen is not allowed. If you use it, it will cause a DRC error, DRC violation. So even if it is not triggered by DRC, it is not acceptable. Okay, so make sure if you are using gold fingers at that specific region, silk screen layer is 100%, it is not allowed. Not even just 90%, 200% it is not allowed. So if you add that, it will fail in manufacturability test. Okay, so it cannot be, silk screen layer and gold fingers cannot overlap with each other. It is completely unacceptable. So yeah. And one more thing is like, there should be something like around 1.5 mm, I think so. It should at least 1.5 mm of uh, gap within the 1.5 mm from the gold finger. There should be no component. There should be no component. Okay, I'll check. See, this is what we told about. No SMD components, plated holes, or shoulder pads are allowed within 1 mm of range of the gold fingers. So here it is mentioned as 1 mm, but usually many people take 1.5 mm. Okay, they usually don't place components within the range of 1.5 mm, but 1 mm is also acceptable. Okay, at least if you're working on some space tight situation, so you can go up to 1 mm. But if you try to put a component less than 1 mm, it will immediately trigger a DRC error. So within 1 mm of range, there should be no component. No component is allowed within 1 mm. Okay, and see, this is the another rule I just now I told. So avoid shoulder mask or silk screen printing near the gold fingers. So you should maintain some gap, not directly print any silk screen or shoulder masks. Shoulder mask is also not available, not allowed at a gold fingers. And the overall length of the gold finger should not exceed 40 mm. So it should be less than 40 mm or equal to 40 mm, but should not exceed 40 mm. So if it exceeds 40 mm, it violates characteristic impedance rule. It violates all other many it causes many it triggers many DRC errors. So signal transmission become hard. It is not reliable for high speed communication. So many complications would be there. So many things are so many things would be happening. So it will leads in a catastrophic failure. So that's why they prescribed this threshold value. Okay, so you can put whatever value that you want, but do not exceed, do not cross 40 mm threshold. So if you cross it, uh, it causes a DRC error. And shoulder mask should not be printed near the gold fingers. Yeah, we already know about it. To enhance the wear resistance of gold fingers, they are typically hard gold plated. Here it is he indirectly saying about ENIG finish, electroless nickel gold immersion. So in that there would be two things. One is soft gold and hard gold plated method. So here he is saying about hard gold plated method. So there are two methods to which you can uh, you know uh, uh, put or incorporate uh, gold layer above the whatever the it copper or nickel layer. So one is soft gold method, which is immersion gold method, and another one is hard gold plating method. Okay, yeah, this is what we discussed about. So gold fingers must be designed with chamfers typically at a 45-degree angle. So other angles such as 20-degree or 30-degree can be chosen. The absence of chamfers in the PCB design of gold fingers indicates a problem. In the image below, the arrow indicates a 45-degree chamfer. See, here he has indicated the 45-degree chamfer. This we call this specific inclination, this pattern we call it as a chamfer. See, these all are chamfers. So you can also choose 20 degree or 30 degree, but what I told is don't go with 20. Okay, at least 30 can be chosen sometimes depending upon the situation. 45 is the standard value. 30 can also, we can also observe 30 degrees uh, no inclination, but don't go with 20 degrees. That's what I'm specifying. We never go with the 20 at Suchna. Okay, so those are the common rules. Okay, about uh, gold fingers. So from today, what we need to understand is we discussed about IPC. What is IPC and its history, which started in 1957. Uh, Around six manufacturing companies of PCB associated with each other, and the main aim objective of the IPC is to uh, publish documentations for PCB manufacturability, and they are having three classes: class 1, class 2, class 3, and the name is also changed later on. Interconnected packaging of electronics. So they also adapted one tagline: association of electronics industry. And then after many industries merged, associated, started joining with IPC. So we discussed about IPC A600, which is also called as visual inspection. So visual inspection specification, where visually checked, the PCB is checked for quality control, like shoulder dissolution, shoulder mask color dissolution. So all these are checked in IPCA 600. So do remember, IPCA 600 is different, IPCTM 650 is different. In IPCTM 650, test methods for PCBs are uh, described, like a rose test, ion chromatography test, and one more test is tape test. Okay, so these are prescribed in IPC TM 650, and in IPC 4552, ENIG, electroless nickel gold immersion method, has been described. And characteristic impedance, track with formula, all these are extracted from IPC. Okay, and yeah, this is about today's session, and we discussed about what are the different rules that we should follow if you are using gold fingers. Like a 45-degree chamfer, we can use 30 degree or 20, but 20 is also allowed. But it's a better to avoid, because it takes so much of space. uh, 20 degrees is usually not acceptable. uh, it is used, but it is according to specification it can be used, but it's better to avoid as much as possible. You can go with 30 degree if you want, as an intermediary value, median range, or else the standard one, 45 degree chamfer. And then shoulder masks and silk screen are not allowed. So usually within 1.5 mm range, no components are placed, but the minimum threshold is 1 mm. So even if the range within 1.5 mm you put a component, it's acceptable. It doesn't throw a DRC error during validation. But if it is less than 1 mm, it will definitely throw a DRC error. And no component, no assembly component, no wires, no pads, nothing is allowed within 1 mm margin. Okay, and then yeah, so these are the things we discussed today. So any questions up to here? So any questions? Just today we discussed about visual inspection and IPC and its history, why they are followed, what are the advantages of following IPC specification, visual inspection test, and then we discussed about what are the common rules that we should follow if we are using gold fingers, like 45-degree chamfers, and not to use the sharp edges. It should be having some inclination, which should be measured in the anti-clockwise direction. It should yield, the result should yield a standard value of 45 degrees. Okay, and it can be 30 degree, it can be inclined at 30 degree with the horizontal axis, and but it should not be less than 20. Even 20 is also, we are not trying to avoid it. So don't put angles less than 20. It is not a standard practice, it is not at all an industrial practice. 20, 30, 45, within these three values we can use. 45 is the standard one. And yeah, Any questions from today's session? Any questions? Okay. So now we will discuss one more concept also. So which is called as ground planes. Okay. So in PCB, ground planes are used. See, if you check this particular design, so here the entire green color region, you are finding this green color. Of course, color can be changed. So don't worry that it is in green color, so it should always be in green color. We discussed about primitive styles, right? Where the styling, how these, the appearance, rendering of these appearance can be changed. Yes, yes, Nihal. What's your question? Any questions, Nihal? Okay. Yeah. So we already discussed how these primitive styles can be changed, isn't it? Around 10 models we discussed, 10 styles, out of which one can be chosen as the primitive style, like Altium Designer, ECAD, RCAD, like that. So many primitive styles. How to change this primitive style in ECAD? We already discussed in the properties in the settings, in the settings panel. We can change the primitive style. So these colors can be changed. It can be customized, customizable. Okay, these colors are can be customizable. So this particular huge area, huge region that you are able to see over here, this is actually called as ground plane. Okay. So can someone tell me what's the voltage for this ground plane? Any idea? Is it 3 volt or 3.3 volt, 1.8 volt, 5 volt? So what's the voltage of ground plane? Any idea? Let me see who will be able to answer. Zero. Anyone? Anyone else? Anyone having different answer like 3.3 volt, 1.8, 1 volt, minus 1? Okay, so it's a 0 volt. So as the name suggests, as the name itself suggests, ground means reference voltage. We are taking 0 ground, right? So ground means 0, so that is called as ground plane. So what this particular thing is equivalent to ground. Okay, it actually carrying 0 voltage, the potential 0. So can someone tell me what are the advantages, why we need to use ground planes in PCB? Why to use ground planes in PCB? Why we use ground planes? See, I am not asking you to share your screen, right? You can take help of AI and you can answer. I know already few people are following that. I know that. Why should we use ground plane? In any PCB, why should we use a ground plane? See, that's your today assignment. So everyone should work on it. Okay. And someone posted something in the chat box. 0 volt. So there are so many advantages of using ground plane. Okay. So like it can also act as heat absorber. Okay. And it can reduce the thermal stress. Okay, thermal stress that can be reduced. And it also acts as like a heat sink. Okay, so though it's a conductor, it carries 0 volt. It can act as like a sink for current as well. It can also act as like a sink for current. And there are so many things, so many applications which we will discuss in the upcoming, if you opt in for higher courses, we will be explaining very in detail uh, in so many applications and about this particular concepts. We are giving you the basic outline. So that's your today assignment about ground plane. And very soon we'll be having one virtual graduation day. So kindly I request everyone to join. So now we will be also seeing many types of heat sinks are used in PCBs. Okay, so many kinds of heat sinks. See, this is one kind of heat sink, another heat sink. See, heat sinks, all these are heat. This is a heat sink which is coupled with a cooling fan. Okay, so now can someone tell me, do you have a cooling fan in your laptop? Anyone not having a fan, cooling fan? So I hope everyone is having, right? So I will ask one question. So if you want to check where, see, right now my fan in my my computer is not rotating. Okay, so usually it rotates when there is huge heat dissipation. So automatically sensors will trigger and activate the fan, and the fan pumps out the hot air to outside by intaking the inhaling. No, it takes a cool air from outside, so it pumps the hot air to outside, right? So now if I want to turn on my fan, okay, forcibly in my laptop to check if my fan is working or not, how to do that? Any idea? So I know how to do that in my laptop. You just check how to do that in your laptops. Okay, yeah, during multitasking. Okay, see, if you are working on huge games which is stressing the IC, okay, if there is huge stress on the IC, if you are performing multitasks, or if you are if you are playing the games which consume so much of memory, and yeah, multi-threaded applications. So if you want to forcibly see in my laptop, I know how to do that. First I need to go to uh, my Asus. There I can find about it. I just don't know how you can forcibly turn on fans in your systems, but I know in my system. So if you just want to check forcibly, if you want to turn on, you need to go to the uh, system diagnosis. So options would be similar, okay, but the application how you need to access them would be a different thing. So under system diagnosis, we will be having a custom diagnosis. Okay, there would be custom diagnosis. See, here you can turn on the fan option, and you can click on checkup. Automatically fan will turn on. So custom diagnosis being tested. So once it reaches something like at 30%, usually at 30% the fan speeds up. Yeah, already my fan started. So as this percentage gradually increasing as progressing, fan speed also usually increases. This is like a diagnosis test whether our fan is really working or not. After completion of test, it will return a report. Okay. So result, fan is working. Okay, like that. So there would be system diagnostic tests. Check with your system, with your operating system, and with your device specific settings. If you are using Linux, options would be different. If you are using Windows, options would be different. But it would be in something option would be looks like custom diagnosis test. Okay, under that option you can find these settings. So usually ICs when used for longer time, they are they uh, gets quickly heated. Lot of heat energy is dissipated, so that that heat should be absorbed by a metal. Okay, because metals are, see, they can they can absorb the heat so quickly, and it can retain the heat. Okay, so they are like good absorbers of heat. Usually aluminum is used. Okay, mostly aluminum is used for heat sinks. So many kinds of heat sinks, see, different kinds. So a heat sink is mounted, affects both thermal performance and mechanical stability. See, in PCB you are having so many things. There is thermal stress test, and there is yeah, thermal stress. Okay, thermal stress analysis. So I will show you how thermal stress analysis looks like. thermal stress analysis of PCB. See, usually we perform after completely designing the PCB, we perform thermal analysis. So this is how our thermal analysis report look like. So from this particular image, we will be able to understand at what specific regions PCB is prone to higher heat. Okay. See, we are having some this particular bar you can see on the right side, right? So based on the color, the temperature can be estimated. Okay. This image seems to be perfect. See, now from this image, you can easily understand that wherever the heat sinks are used, so those regions are appears to be little bit bluish color, not red color. Why? Because heat sinks absorbs the heat, so that's why it is showing like that. So from this we need to understand that heat sinks are essential. Okay, it's not something that needs to be that can be avoided. Okay, so we perform heat thermal stresses. Okay, thermal stress analysis, thermal stress analysis. So this can be performed in CAD test. Okay, CAD test or CAD tools. So here we are having some MOSFETs, isn't it? There is so many things. Okay, even for selection of uh, you know heat sink, there would be, we need to calculate the heat load. Okay, so by calculating that, based on that we need to choose these heat sinks. So this is just an intro. Complete details will be provided in the, if you opting for higher courses. So we are having a separate advanced courses where we'll be discussing about thermal stress analysis, and in detail about many uh, unrevealed IPC uh, uh, specifications that are industrially, followed in industries. So what we told you is just the basics, it's just the beginning of your journey. Okay, yeah. So this is today's session. So assignment is what, don't go in detail, just only try to understand what are the advantages of using ground planes, and also what are the disadvantages. Okay, I want both. What are advantages of using ground planes and what are disadvantages of using ground planes. So these things you just analyze and submit a report. It's not mandatory, it's voluntary. If you want to do something like a research, you do. Okay. Yeah, so this is today's session where we discussed about intro to heat analysis. We also discussed intro to heat analysis, thermal stress analysis, and we use so many kinds of uh, heat sinks and cooling fans in PCB. So not just drawing schematic and turning into PCB, placing components, doing routing is not what actually a PCB means. Behind that, so much of science is there, so many interesting things are there. What we told you is just 25% or 20% out of 100. Okay, so thank you for joining today's session. This is your expert mentor Hemant. Probably we will be having one more session. Okay, so by that session our course is completed. So actually I need to tell about ground planes today, and I need to close the session by today itself, but I want to tell you something interesting more. So that's why I told about visual inspection, and I told about we perform thermal analysis, and we use heat sinks, and what are the rules. Not only just adding gold finger itself is out of concept, out of our schedule, but still I told you not only the gold fingers but how to add chamfers. Okay, I mean We need to do that practice of like 45-degree angle is the practice. And I told you few rules, couple of rules. Silk screen layers not allowed, shouldering. Yeah, all these things we discussed today. So I hope it is clear. Now I request everyone to kindly please react with thumbs, emojis. Don't forget that every session should be ended in the same way. It shows your energy, enthusiasm. Everyone, quickly keep on pressing emojis until I end the session. Still, everyone, I want everyone to use thumbs and emojis. I will also use. Okay. Yeah. So thank you for joining today's session. This is your expert mentor Hemant from Suchna signing off. Bye bye. Yeah. So announcement. So those who want to, we will give you a chance to share your feedback during virtual program. We are conducting a virtual program. It is going to be amazing. So those who are interested to speak, give feedback about Suchna on the graduation day. So kindly please raise your hand. Those who are interested to share your feedbacks. See, your feedbacks are recorded. Okay. So every program we record. So it would be great opportunity for you to talk during the session. We'll be having the founder of Groyota LLP, Shri S. Daniel, in our session. He will be discussing about our future activities, our future product launches, future plans, and how you can get involved in Suchna activities. How can you contribute to Suchna? And in turn, what are the things, what privileges we provide to you? So, how to join the executive council? We are having an EC executive council where administrative related informations will be provided to the EC members, and so it's like a voluntary R&D. So by contributing to Suchna, you can also gain so much of knowledge. Okay, so how you contribute to Suchna and what are the different ways through which you can get involved in our activities, that will be uh, explained in the graduation day. So yeah, I will ask one by one. So what kind of things that you can do on that program? You want to share feedback, or if you are, some people may draw our Suchna logo. If you are having art skills, those logos may be presented. And if you want to write something, a story, or if you publish an article on Suchna, or if you give review means not just posting in Trustpilot. Okay, so you need to post some article on how how activities at Suchna are going on. So what kind, you can draw some, you can write some poems on Suchna. Yeah. So thank you for joining today's session. Signing off. Bye bye.